Good day everyone, my name is Hershey Salvana and I will be reporting about road tars and properties of asphalt materials. So first, let us tackle about road tars. Road tars are available naturally in the wood taken from trees, peat, and coal taken from the ground through exploration. It is a viscous liquid, black in color, thick and flammable product obtained from the residual in the absence of air, and it consists of hydrocarbons along with other organic compounds. In addition, it is a byproduct obtained from destructive distillation of coal. Next, road tars is manufactured to exist in liquid state and also in semi-solid state depending on the purpose of application. It is graded based on the viscosity of the liquid. And in the case of semi-solid state, the gradation is done based on hardness. Road tars are used as a glue, mixing the aggregates well and in forming bituminous concrete. It is highly water resistant in nature. So the American Society for Testing Materials, or ASTM, has classified road tars into three general categories based on the method of production. First is the gas house coal tars, which are produced as a byproduct in gas house retorts in the manufacture of illuminating gas from bituminous coals. The second one is the coke oven tars that are produced as a byproduct in coke ovens in the manufacture of coke from bituminous coal. And the third and the last one is the water gas tars that are produced by cracking oil vapors at high temperatures in the manufacture of carbureted water gas. Road tars is also have been classified by ASH2 into 14 grades, RT1 through RT12, RTCB5, and RTCB6. So RT1 has the lightest consistency and can be used effectively at normal temperatures for prime or tack coat. RT12, which is the most viscous since the viscosity of each grade increases as the number designation increases. Then the RTCB5 and RTCB6 are suitable for application during cold weather since they are produced by cutting back the specific grade of tar with easily evaporating solvent. Detailed specifications for the use of tars are given by ASH2 designation M52 to 78. So, that is all for road tars. Next will be the properties of asphalt materials. So, there are the properties of asphalt materials pertinent to pavement construction can be classified into four main categories. First is consistency, then aging and temperature sustainability, then rate of curing, and lastly, resistance to water action. So first, what is consistency? Consistency of The consistency properties of an asphalt material usually are considered under two conditions: the variation of consistency with temperature and consistency at a specified temperature. So, what is the variation of consistency with temperature? It is the consistency of any asphalt material changes as the temperature varies. The change in consistency of different asphalt materials may differ considerably even for the same amount of temperature change. For example of this is If a sample of blown semi-solid asphalt and a sample of semi-solid regular paving grade asphalt with the same consistency at a given temperature are heated to a high enough temperature, the consistencies of the two materials will be different at the high temperatures, with the regular paving grade asphalt being much softer than the blown asphalt. Further increase in temperature eventually will result in the liquefaction of the paving asphalt at a temperature much lower than that at which the blown asphalt liquefies. So, if these two asphalts then are cooled down gradually to about the freezing temperature of water, the blown asphalt will be much softer than the paving grade asphalt. Therefore, the consistency of the blown asphalt is affected less by temperature changes than the consistency of regular paving asphalt. This property of asphalt uh, this property of asphalt materials is known as the temperature susceptibility. So, temperature susceptibility depends on the crude oil from which the asphalt is obtained. Although variation in temperature susceptibility of paving grade asphalts from different crudes is not as high as that between regular paving grade asphalt and blown asphalt. So next is the consistency at a specified temperature. So as stated earlier, the consistency of an asphalt material will vary from solid to liquid depending on the temperature of the material. And it is therefore essential that when the consistency of an asphalt material is given, the associated temperature also should be given. Next, properties of asphalt materials is the aging and temperature sustainability. So, when asphaltic materials are exposed to environmental elements, natural deterioration gradually takes place and the materials eventually lose their plasticity and become brittle. This change is caused primarily by chemical and physical reactions that take place in the material. So, weathering, the natural deterioration of the asphalt material is known as weathering. Then, let us take note that for paving asphalt to act so successfully as a binder, the weathering must be minimized as much as possible. And the ability of an asphalt material to resist weathering is described as the durability of the material. And there are some factors that influence weathering, which are oxidation, volatilization, temperature, and exposed surface area. So, first, oxidation. Oxidation is the chemical reaction that takes place when the asphalt material is attacked by oxygen in the air. This chemical reaction causes gradual hardening, eventually permanent hardening, and considerably loss of the plastic characteristics of the material. Next is volatilization, which is the evaporation of the lighter hydrocarbons from the asphalt materials. The loss of these lighter hydrocarbons also causes the loss of the plastic characteristics of the asphalt material. Then, next is temperature, which it has been shown that temperature has a significant effect on the rate of oxidation and volatilization. Thus, the higher the temperature, the higher the rates of oxidation and volatilization. The relationship between temperature increase and increases in rates of oxidation and volatilization is not linear. However, the percentage increase in temperature that causes However, the percentage increase in rate of oxidation and volatilization is usually much greater than the percentage increase in temperature that causes the increase in oxidation and volatilization. It has been postulated that the rate of organic and physical reactions in the asphalt material approximately doubles for each 10 C increase in temperature. Next is the surface area. The exposed surface of the material also influences its rate of oxidation and volatilization. There is a direct relationship between surface area and rate of oxygen absorption and loss due to evaporation in grams per cubic centimeter per minute. So the next properties of asphalt will be the rate of curing. First, what is curing? So curing is the process through which an asphalt material increases its consistency as it loses solvent by evaporation. So rate of curing indicates the time that should elapse before a cutback will attain a consistency and simultaneously the binder to perform satisfactorily. Then, next is the resistance to water action. It is important that asphalt continue to adhere to the aggregate even with the presence of water. It is because of the fact that asphalt will strip from aggregate if the bond is lost, which will result in deterioration of the pavement. That is all. Thank you for listening. Ciao.